You shipped automation to kill manual work, and somehow you are reviewing more than ever. The model looks confident, the dashboards look green, and the real damage shows up weeks later in refunds, escalations, and angry audits. Quiet errors slick through. Loud tickets bury your team. Edge cases hide in logs nobody reads. And the worst part is that you feel safe because a number said high confidence. That is not proof. Proof starts with deciding what actually counts. Moving to slide 2. Stop treating this as a prediction problem. Treat it as a decision you are responsible for. Write down the decision in plain language, like approve this invoice, publish this listing, or route this claim. Then assign one outcome owner, one person or role who will answer for wrong calls and who can change the acceptance criteria. Now make the criteria explicit, not high accuracy, specific, testable outcomes. For example, auto-approve only when the expected financial downside is under $50 per 1,000 decisions. Or, false approvals must be under 0.2% for enterprise customers. Or anything with missing tax ID must never be approved. Price the mistakes. List the cost of a false accept, a false reject, and a delayed decision. If a false accept is catastrophic, your system should be biased toward escalation. If delay is expensive, your fallback needs a fast, good enough path. Finally, define allowed fallback outcomes up front. Escalate to human. Ask for more data. Return cannot decide. If you cannot describe success and acceptable failure, you cannot build a gate that protects you. Moving to slide 3. Now you wrap the model with a decision gate that has only 3 outputs: pass, fail, or escalate. The gate is not the model's raw label. It is a deterministic policy layer that reads model scores, input validity, and business rules, then produces an auditable decision with a reason. Every auto-approval must have a logged justification, and silent pass is banned. If you cannot explain why it passed, it did not earn the right to pass. Moving to slide 4. Raw confidence is a liar unless it is calibrated. You care about whether 0.9 actually means right about 90% of the time on your data today. Check calibration by segment, not just overall. New vendors, new geographies, long-tail products, and high-dollar cases often behave differently. Use a margin check between the top 2 classes. If the best option barely beats the runner-up, that is uncertainty, even if the top score looks high. Build abstention into the workflow. When the model is unsure, the correct action is to not guess. Add out-of-distribution detection. If the input looks unlike training data, treat it as risk and escalate or request more fields. Your goal is not to sound confident. Your goal is to know when you should not decide. Moving to slide 5. Before you reach for fancy model changes, add cheap guardrails that catch dumb failures. Start with schema and type checks. If a field is missing, the type is wrong, or a date is impossible, hard stop. Then enforce allowed ranges and enums. No negative quantities. No currency codes you do not support. No discount over your policy cap. Use regex for known formats like tax IDs, IBANs, phone numbers, and SKU patterns. Do reference lookups. If a vendor ID does not exist, stop. If the address cannot be normalized, escalate. If the product is not in your catalog, do not publish it. These rules are not anti-AI. They are seatbelts. They cut the ticket volume, shrink the edge case surface area, and turn a messy stream into something you can measure and trust. Moving to slide 6. When your system throws exceptions, the fastest way to lose control is letting everyone describe them differently. Turn noise into signals by forcing every exception into a small set of reason codes, not a paragraph, a code. If you need nuance, add one secondary tag, but keep the first code stable so you can count it and trend it. Use a single escalation taxonomy. Define what needs human review means, what blocked means, what auto-resolved means, and what policy violation means. If 2 teams use different labels for the same thing, you will never know where time is going. Ban free text chaos. Allow notes, but only after structured fields are filled. require minimal evidence attached to the case. One screenshot, one log snippet, one request ID, one model output, whatever proves the claim. Not 10 attachments. Then timebox human work. Set a hard limit like 8 minutes per case before it must be escalated or parked. Your goal is not perfect handling in the moment. Your goal is clean, consistent signals that can feed an orderly queue. Moving to slide 7. Once you have clean signals, you need a triage queue that respects business reality. Sort first by business risk, not by who is shouting loudest. High risk could mean regulatory exposure, user harm, revenue loss, or brand trust. Pick the risk dimensions up front and score each exception class once. Then reuse that score. Group similar exceptions so one fix clears many cases. If 10 tickets share the same reason code and the same failure pattern, they should be reviewed together. That also makes it obvious when you are dealing with a systemic issue versus a one-off. Deduplicate aggressively. Use stable fingerprints like customer ID plus reason code plus policy version plus input hash. If the same failure repeats, you want one master case with a counter, not 50 separate threads. Route by domain expertise. Privacy issues go to privacy. Payments go to payments. Prompt safety goes to safety. The fastest resolution comes from the fewest handoffs. Track an SLA per class. A chargeback risk class might be 4 hours. A low-impact formatting issue might be 3 days. When the queue is structured, your team stops reacting and starts making deliberate trade-offs, and those trade-offs become data. Moving to slide 8. Every human decision you make during triage should be captured like training data. Even if you never train a model, start with the final resolution. Approved, rejected, escalated, refunded, policy exception granted, policy exception denied. Make it a required field. Store the counterfactual output. That means saving what the system would have done without human intervention, alongside what the human actually decided. If you only store the final outcome, you cannot measure whether automation is improving or just changing. Require a short rationale, but constrain it. 2 sentences max, and include a required checkbox list for the most common reasons. Humans are great at nuance, but metrics need structure. Log the policy version used. Policies change, thresholds change, prompts change. If you cannot tie a decision to the exact rule set in effect, you will argue later and lose. Enable replay. Save the inputs, the model version, the features, and the decision record so you can rerun old cases against new logic. When you can replay, you can test proposed changes against real history, and your good judgment turns into an asset you can repeatedly apply. Moving to slide 9. Closing the loop is where teams accidentally create new failures while fixing old ones. Set a weekly exception review, where you look at the top reason codes, the highest risk classes, and the longest aging cases. Pick a small number of changes to ship, not a long wish list. Promote new guardrails carefully. If humans keep overriding for the same reason, encode that reason as a rule, a UI constraint, or a safer default. Update thresholds by slice, not globally. What works for enterprise users might break for new users. Add targeted test cases for every change, using real exceptions as templates. Then ship small and verify fast. One change, one measurable expectation, one rollback trigger. That is how you improve automation without eroding trust. And it sets you up to prove your system holds under pressure. Moving to slide 10. Test like it will break. Keep a golden set per segment, not one universal benchmark. Add adversarial edge prompts that mirror how users actually try to bypass rules. Use canaries on real traffic, plus shadow mode comparisons, so you see differences before users do. Rehearse rollback like a routine task, not a panic move. When tests assume failure, releases stop being bets and start being controlled experiments humans can actually rely on. Moving to slide 11. If your AI review system only tracks model accuracy, you will miss what humans actually feel. Monitor escalation rate by slice so you know which categories, teams, or vendors are triggering handoffs. Track false pass incidents because one quiet miss can erase trust. Watch queue aging and backlog to prevent slowdowns from becoming normal. Trend top reason codes so fixes target the real failure modes, and measure cost per resolved case, not cost per ticket. When these are visible, quality becomes controllable. Moving to slide 12. Security and compliance are not a checkbox you add later. They are the conditions that decide whether your system can operate at scale. Start with least privilege access. Reviewers should only see the minimum data needed to make a decision, and only for the cases assigned to them, with time-bound access when possible. Redact sensitive fields before they reach the model or the reviewer. Do it by default, then allow tightly governed exceptions, not the other way around. Make audit logs immutable. If a decision can be contested, you need a tamper-resistant record of inputs, outputs, and edits. Tie every action to a human identity, including approvals, overrides, and bulk operations. If someone asks, you should be able to answer who changed what, when, and why in one query. Finally, control vendors and models like you would any production dependency. Pin versions, document what data can be sent, enforce retention limits, and require incident reporting timelines. When your controls are precise, you can move faster without betting the company on trust. Moving to slide 13. Keep the rollout simple. Start with one workflow where humans already review outcomes. Then add AI support without changing the goalposts. Set an escalation budget so you know how many handoffs you can afford per day and what happens when you hit that limit. Define success metrics up front, including error severity, time to resolution, and reviewer agreement. Train reviewers with concrete examples of good calls and bad calls so decisions stay consistent across shifts. If you want more scripts like this, subscribe, then comment with your rating from 1 to 10. Tools evolve. Principles endure.